Hello, welcome to the eighth lesson of this course. Today we will be covering Unit 9 of Book 1. In this unit, we are going to talk about SI units. Okay, so we're going to talk about the different SI units. We're going to talk about what they measure, what formulas they use, and so on. Let us begin. All right, for our first warm up of this unit, I want you guys to read through this passage, the Understanding SI Units passage over here. And once you're done reading, I want you guys to answer these two questions over here. The first one asks, what is the difference between a base unit and a derived unit? And the second one asks, what units can be calculated using kilograms, meters, and seconds? Okay, so read through the passage, pause this video, answer those two questions by yourselves first. And once you're done, resume the video and we'll go through the answers together. Here are the answers. For the first one, what is the difference between a base unit and a derived unit? Well, a base unit just measures one factor of something. So it measures weight, length, or time, so just one thing. But derived units are determined by the relationship between base units and sometimes can be calculated using a formula with only one base unit. So it's sort of like, while the base unit only has one thing, the derived units might have multiple things involved in order to solve them, like a formula, right? We'll get into more detail about that as we go through this unit. For the next one, what units can be calculated using kilograms, meters, and seconds? Kilograms, meters, and seconds are all base units that can be used to calculate newtons, Pascal, and joules. Okay, so all three of these use a combination of kilograms, meters, and seconds. Okay, so that was the warm up. Moving on. For the second warm up, I want you guys to read through the poster again. And after you read through it, select whether the following statements are true or false. So we have these three statements down here. The first one says, molar mass is measured with a derived unit. Newtons and pascals are two ways to measure the same property. And lastly, energy and pressure are calculated with the same base units, okay? So read through the passage, pause the video, and select true or false for each of these statements. Once you're done, resume the video and we'll go through the answers together. Here are the answers. For the first one, molar mass is measured with a derived unit. The answer to this one is true. As we see here in the second paragraph, they mentioned that molar mass is kilograms per mole. Mole is a derived unit. All right. Next, newtons and pascals are two ways to measure the same property. The answer to this one is false. Newtons measure force, while Pascal measures pressure. These are two different properties. And the last one, energy and pressure are calculated with the same base units. The answer to this one is true. Both energy and pressure use kilograms, meters, and seconds as their base units. Okay, so those are the answers. Moving on to the next segment. For the vocabulary segment of this unit, I want you guys to match the following words with the following definitions. So we have molar mass, mole, base unit, force, amount, and Pascal. So I want you to match each of these words to each of these definitions. I want you to try that yourselves first. Pause the video, try it yourself. And once you're done, resume the video and we'll go through the answers and definitions together. Here are the answers. So for a physical quantity of something, we call that one an amount. So an amount is a physical quantity of something. So the amount of apples, the amount of candy, and so on. Next, a unit that measures pressure, we call that one a Pascal. So that's the unit that measures pressure. Next, a unit that represents large quantities of small things. We call that one a mole, okay? So they represent large quantities of small things. Next, one of 7 SI units that determine other units. This one is a base unit. So we were talking about base units earlier, like kilograms, seconds, and meters. Those are base units. Next, a relationship between mass and amount of a substance. We call that one a molar mass, right? And the last one, the ability to cause physical change is force. So physical change like moving something or dropping something and so on. Those are the answers for this segment. Now we're moving on. For this section of the vocabulary segment, I want you guys to read the sentences and choose the correct words or phrases for each sentence. So for each of these sentences, you have 2 choices. For the first one, you have newtons and moles. For the second one, you have SI and amount. For the third one, you have pressure and force. For the fourth one, you have molar masses and derived units. And the last one, you have base unit and joule. So I want you guys to try reading out these sentences yourselves first. Fill out the blanks yourselves first. Pause the video, do all of that. And once you're done, resume the video and we'll go through the answers together. Here are the answers. So kilograms, meters, and seconds are used to calculate newtons. As we've seen earlier in the warm-up, the newtons uses all 3 of these base units, moles do not. Next, many base units in the SI come from the metric system. So we were talking about how there were 7 different SI base units. So they belong in the SI. Next, pressure is the quality that the Pascal measures. So we already mentioned earlier that Pascal measures pressure. Next, some derived units apply a formula to just 1 unit. Again, we mentioned that earlier in the warm-up. And the last one, a joule is a unit of work or energy. That was shown in the poster. So joule is a unit of work or energy. Okay, those are the answers. Now we move on to the next segment. For the next section of this unit, I want you guys to listen to the audio clip of the poster that we've been using for our warm-up. After you finish listening to the audio clip, I want you to fill in the blanks on the following incomplete paragraph down here using the given vocabulary, joule, factors, energy, Pascal, and base. All right? So listen to the audio clip, pause the video, fill it out yourselves first, and when you're done, resume the video for the answers. Here's the audio clip.
Unit 9, SI Units, Exercise 5, page 21.
Understanding SI units. The SI features many derived units. These are determined by relationships between the base units. To calculate derived units, you must know the base units. For example, the derived unit for molar mass is kilograms per mole, m. This is the relationship between mass and amount of a substance. It requires 2 base units, kilograms, kg, and moles, mol. The formula is kilograms divided by moles. M equals kg divided by mol. These derived units all use the same base units. Base units, kilograms, meters, seconds. Derived unit, Newton. N, measurement, force, formula, N equals kilograms times meters per second squared. PA, derived unit, Pascal. PA, measurement, pressure, formula, PA equals kilograms per meters times second squared. J, derived unit, joule. J, measurement, energy, formula, J equals kilogram times meters squared over second squared.
Okay, so that was the audio clip. Here are the answers, okay? Newtons, pascals, and joules all use the same base units, but they measure different factors. A Pascal is the pressure exerted by 1 Newton over a meter, and a joule, the amount of energy it expends. Okay, so those were the answers. Moving on. For the next listening segment, I want you guys to listen to a conversation between two scientists. Afterwards, you choose the correct answers for the following two questions. The first one asks, what is the conversation mostly about? And the second one asks, what measurement do the scientists need? Okay? So after you listen to the clip, pause the video, answer these questions yourselves first, and then resume the video for the answers. Here's the audio clip.
Exercises 6 and 7, page 21. Something's not right in our experiment.
What do you mean? The machine isn't functioning?
It looks fine, but it's hardly performing any work.
How much energy is it using?
According to my calculations, it's only at 200 joules per second.
Let me take a look. Hang on, I see what happened.
Really? What is it?
You forgot to square the meters. This is the formula for force, not energy.
Oh, I calculated newtons. Let's see. With meters squared, I get 1,000 joules.
That makes more sense.
Okay, so that was the audio clip. If you need to listen to it again, rewind this video to the point where I began the clip. Here are the answers. So, what is the conversation mostly about? It is mostly about an error in the woman's calculations. So she was complaining about the lack of energy, and it turns out that she just made the wrong calculation. That's what they were mainly talking about. Next, what measurement do the scientists need? They were measuring energy, right? They're talking about the machine's energy and what they need to do to calculate joules. All right. So those are the answers to this segment. Moving on. For the third part of the listening section, I want you guys to listen to the conversation again and then fill in the blanks of the conversation over here. So just like before, you listen to the conversation, pause the video, and fill in the blanks yourselves first. When you're done, resume the video, and I'll show you what it looks like, okay? Here's the conversation.
Exercises 6 and 7, page 21. Something's not right in our experiment.
What do you mean? The machine isn't functioning?
It looks fine, but it's hardly performing any work.
How much energy is it using?
According to my calculations, it's only at 200 joules per second.
Let me take a look. Hang on, I see what happened.
Really? What is it?
You forgot to square the meters. This is the formula for force, not energy.
Oh, I calculated newtons. Let's see. With meters squared, I get 1,000 joules.
That makes more sense.
Okay, that was the audio clip. If you need to hear it again, rewind this video to the point where I began the clip. Here are the answers. Something's not right in our experiment. What do you mean? The machine isn't functioning? It looks fine, but it's hardly performing any work. How much energy is it using? According to my calculations, it's only at 200 joules per second. Let me take a look. Hang on, I see what happened. What? Really? What is it? You forgot to square the meters. This is the formula for force, not energy. Oh, I calculated newtons. Let's see. With meters squared, I get 1,000 joules. That makes more sense. Okay, so that was the conversation. Now we're moving on to the next segment. For the speaking segment of this unit, I want you guys to read the following conversation and then try to figure out which of these given sentences belong to which blank. So you have 3 sentences here. I calculated pascals. Something's not right in our experiment. And according to my calculations, it's only at 200 newtons. So I want you guys to pause this video, select which sentence belongs to which blank. And then when you're done with that, practice speaking out this conversation either by yourself or with a partner. And after you do all that, you may resume the video and I'll show you what the conversation looks like. Here's what the conversation looks like. Something's not right in our experiment. What do you mean? The machine isn't functioning? It looks fine, but it's hardly producing any force. According to my calculations, it's only at 200 newtons. Let me take a look. Hang on, I see what happened. You divided by the meters. This is the formula for pressure, not force. I calculated pascals. With meters multiplied, I get 800 newtons. That makes more sense. Okay, so that was the conversation. I hope you guys have the same thing. Moving on. For the last segment of this unit, I want you guys to fill in the blanks of this note over here, right? Now you can use the conversation from the previous segment to help you fill in the blanks, but you could also look at these 2 calculations here. So you have an incorrect calculation and a corrected calculation. So if you pay attention to these 2, you should be able to also fill in the blanks by yourselves. I want you guys to try to pause this video and try fill in the blanks yourselves first. And once you're done, resume the video and we'll go through the answers together. Here are the answers. The problem was I used the formula for newtons instead of joules. To apply the correct energy formula, I needed to square the meters. Okay, as you can see here, you have the incorrect calculation up here. This is a formula for newtons. The corrected calculation is down here, which is the one for joules, right? They use meters squared. All right, so those were the answers for this segment. And yeah, that's it for this unit. Okay, so that was the last activity of this unit. If you guys need any additional help, you will have access to the vocabulary PowerPoint, which has the definitions of all the vocab we covered for this unit, as well as the Thai word equivalent. I hope to see you guys for the next unit. See you later.